Project title is Lightweight Machine Learning Based Intrusion Detection System for IoT Healthcare Devices. In the recent years, the Internet of Things has played a major role in transforming healthcare systems. IoT devices such as ICU ventilators, patient monitoring systems, wearable health sensors, and vaccine cold storage units continuously collect and transmit critical medical data. This real-time connectivity helps doctor and the healthcare staff to monitor the patients effectively and make the medical decisions faster. However, the increasing use of IoT devices in the healthcare also introduces a serious cybersecurity risk. These devices often have limited computing power and weak built-in security, making them attractive targets for the cyber attacks such as ransomware, denial of service attacks, and brute force attacks. A successful attack can lead to a data breaches, disruption of medical services, or even life-threatening situations. To address these challenges, our project focuses on developing a lightweight machine learning based intrusion detection system for our IoT healthcare environments. The goal is to monitor system and network behavior in the real time, detect malicious activities yearly, and alert the administrator without relying on the expensive hardware based security solutions. So, in the current healthcare environments, security is mainly provided using traditional intrusion detection system and the basic network security tools. These are commonly classified into two types. They are hardware-based IDS and rule-based software IDS. So, what is hardware-based IDS? Hardware-based IDS is detection system use dedicated devices such as firewalls, gateways, and network sensors to monitor traffic. While these systems provide basic protection, they are expensive to maintain and deploy. So they also lack flexibility and are difficult to scale as the number of IoT devices in their hospitals increases. And rule-based software ideas is basically used to detect the attacks by comparing the network traffic against the predefined rules or some known attack signatures. Although these systems are easier to deploy than hardware solutions, they suffer from major limitations. They cannot detect new or unknown attacks or often generate false alerts. Additionally, they do not adapt to changing attack patterns. So, the basic limitations of the existing system is because of high cost and maintenance overhead, poor scalability for large IoT healthcare networks, cannot detect zero-day or unknown attacks, and no learning or adaptive capability is there. Because of these limitations, existing systems are not sufficient to protect these IoT based healthcare infrastructure. So we produce a proposed system to overcome these limitations, and we propose an idea like lightweight machine learning based intuition detection system, designing specifically for the IoT healthcare devices. The proposed system continuously monitor the system and the network metrics such as CPU usage, memory usage, network traffic, activity, and logging failures. These metrics are analyzed using machine learning algorithms to classify their behavior either they are normal or malicious. Unlike the traditional methods, we propose these systems which uses machine learning for adaptive learning. This software based and cost effective detects both malicious and normal attacks efficiently and also detects the known and unknown attacks. Works efficiently on the resource constrained IoT devices. So, this system is capable of detecting common attacks like ransomware, DDoS, and brute force attacks in the real time and generate the alert to notify the administrator immediately without causing any damage. Now, let me explain the code detail. So, the implementation of the code is like main modules are data generation, model training, and the real time dashboard training. So, the purpose of this is like real time hospital network data is confidential and not publicly available. We generate a synthetic but realistic data that simulates the IoT healthcare network behavior. The code uses NumPy and Pandas to generate the random data. The random seed is set to ensure the reproducibility, The four types of traffic we usually is generated using these data set are normal traffic, which caused by low CPU, low network traffic, and minimal login failures. And the ransomware attack is like when CPU is high and the disk write is due is file to encryption. And the DDoS attack is like extremely high network packets indicating traffic flooding. Brute force attacks is high number of logins attempts. So all this data is combined together, shuffled and cleaned, and are saved as a CSV file and is named as hospital underscore IoT underscore network dot logins dot CSV file. This dataset acts as a fundamental and a foundation for the training of machine learning model. So in model training, that is model underscore train underscore model PY, this is used to train the machine learning models using the intrusion detection. In this code, the CSV file is loaded already in the VS Code, and the five system matrices are selected. As I mentioned above, like CPU usage, memory usage, network packets, disk write speed, and login failures. The target variable is the attack type, like what attack is to be shown at what time. And the data set is split into training and testing set to avoid the overfitting. The main classifier we have used here for the training purpose is the random forest, which is a base forest. So why we have choose random forest? Because it gives high accuracy, handles some multiple features very well, resistant to overfitting, and it's especially very good for the lightweight when compared to the deep learning models. So I have saved this train.py, which produces a .pkl file, which serves as intelligence of ideas. And now app.py. This is the real-time intrusion detection dashboard, and we used a Streamlit uh, base. The code is like we have trained the model. It's loaded using joblib. The catching is applied to improve the performance, and the dashboard provides two basic operation modes. Like we have introduced about like both manual testing mode and live monitoring mode. So live monitoring mode automatically stimulates normal and attack traffic, while the manual mode allows the user to manually control the system parameters. So how this work? This logic works like when the input system matrices are passed to the train model, the model predicts the attack type and confidence scores. If the normal behavior is detected, a green secure message is shown. If the attack is detected, a red alert shown is displayed with the detailed details of the attack. And we have introduced a new creative idea of adding an incident history log, which helps us to find that when the attack is when the attack happened on at which time and what attack especially happened. So all the events are logged with time, status, and attack type and confidence. Very useful for monitoring, auditing, and even for the forensic analysis. So, how this project actually work? Like in the future works and enhancement. Although this proposed system is like effective and our ideas are very good, we want to implement them in future to increase its productivity and efficiency. And by integrating the deep learning models for complex and complex attack detections, deployment of real IoT devices, healthcare devices, so it may help in detecting them in a faster way. So now I'm going to show the simulation of our prototype. So we have used the real-time ideas dashboard and I've saved it as app.py. The purpose of this model implementation is like real-time intrusion detection dashboard using a Streamlit. This is the code I have imported. Like the train model is loaded using the job lib, and the catching is applied to improve the performance. So the dashboard is providing like basic two operating modes. So one is a live monitoring mode, and the other is the manual testing mode. So live monitoring mode is used to automatically simulates the normal and the attack traffic, while the manual testing mode which allows the user to manually control the system parameters. So, what is the detection process of this? So, the logic is like input system matrices are passed to the trained model. The model predicts the attack type and confidence code, like what attack is done. If the normal behavior is detected, then the green secure message is shown. If the attack is detected, then the red alert is displayed with the attack details. So, by giving a creative idea, we have imported in adding an incident history log base in which all the events and the logged with the time, status, and attack type and the confidence are mentioned, which is useful for monitoring, auditing, and even for the forensic analysis. So, how this works in future? Although we have proposed a system performance effectively, several enhancements must be done to implement this in future, like deploymenting the on the real-time IoT healthcare devices and integrating a deep learning models for the complex attack detection. Intrusion of more attack categories must be included, so it may help us to detect various types of attacks real time, and the real time integration with the hospital security infrastructure, which proves that logs and the history of it may help in future. So these enhancements must be done in the further coming days to improve accuracy, scalability, and the real world applicability. So to conclude, in this project, we have presented the lightweight machine learning based intrusion detection system for the IoT healthcare devices. The system effectively monitors system behavior, detects cyber threats in the real time, and alerts the administrator without relying on the expensive hardware solution. By using the machine learning techniques and the system level matrices, the proposed ideas overcomes the limitations of basic traditional security systems. It is cost effective, scalable, and suitable for the resource constrained IoT devices. So overall, this project demonstration is demonstrates like how intelligent software-based system solution can significantly enhance the safety, reliability, and the privacy of the IoT-enabled healthcare systems. So, thank you.